welcome back to my channel. I'm Ashley Morris, the owner and lead tutor at amtutors.com. And in this video, we are wrapping up solving systems of equations by graphing. I wanted to show you something that can happen that's like kind of funky. So there are some special cases when we're solving these, so I want to talk about them here. So this first equation, we can graph it as is. It's already y by itself. So I'll do this one in this like yellowy green color. So we're going to go up to 4. 1, 2, 3, 4. Yay, it fits on my graph. Then we're going to go down 1, over 2 to the right, so we get negative slope. And then we're going to go ahead and connect our dots now so we don't get confused about which dots go with which line. So there's that first one. Now the second one, we need to get y by itself. It's in standard form. Let's get y by itself. Subtract x from both sides. Divide everything by 2 to get the y all the way by itself. Y equals negative 1/2 x plus 4. That's the exact same equation. So when I go to graph it, I'm going to get the exact same line. These two lines are the exact same equation. That means our solution is infinitely many solutions. There's a bajillion, that's not a real number, we're going to pretend it is. There are so many points where these are the exact same because they're the same everywhere. It's on top of this line, both of them. So there's infinitely many solutions. Sometimes our teachers let us abbreviate IMS. There's a bunch of different ways you can abbreviate it, so see how your teacher wants you to write it. But we had the exact same equation, so we have the exact same line. They sit right on top of each other. They are the same everywhere. So infinitely many solutions, or IMS. See how your teacher wants you to abbreviate it. Okay, so let's take a look at this one. We've got two different forms of a line, so we can't graph that second one yet. Let's go and graph the first one, and then we'll deal with the second one. So that one, I'm going to go up to 3. 1, 2, 3, and put a dot. And then my slope was 1. There's an invisible 1 in front of that x. So up 1, over 1, or I can go down and left. If they're both negative, down is negative, left is negative, I still have the right slope. Down and left. Okay, connect my dots so I don't get confused about which dots go with which line. Okay, there's that one. Now let's look at the second one. We're going to subtract x because we got to get y by itself. I'm noticing some similarities, but I'm not going to make any decisions until I finish. I got to get rid of this negative. So divide everything by negative 1 or multiply, same thing. X minus 3. Okay, so they're not exactly the same. That's a plus 3, that's a minus 3. So we have different y-intercepts, but we have the same slope. So let's go down to 3. 1, 2, 3, and put a dot. And then we've got the same slope. Well, when we were, go up, over, when we were solving and writing the equations of lines and stuff like that, we found out that if they have the same slope, these are parallel lines. Same slope, different y-intercept. These are parallel lines. Are they ever going to be the same? They are parallel forever and ever and ever. So this one actually has no solution. We abbreviate that with a circle with a line through it, or you can write no solution. The answer is not that they are parallel lines. That's describing what happened with the lines. The solution is there isn't one. They will never, ever be the same. So parallel lines, no solution. If it ends up being the exact same equation and they graph on top of each other, it's the same line, infinitely many solutions. I hope this was helpful. If you have any questions, please reach out to us at amtutors.com. We would love to meet with you one-on-one with our certified math teachers to get you some extra help. Also, like and subscribe so you always get the latest and greatest math content when we post it. Have a great day.